Hi there, this is another video about the chapter 3. Okay, so I told you this chapter is a little bit longer and let me check. Okay, my microphone is recording. So let's continue. This is this video is going to be shorter. Okay, now don't talk about if this video is going to be longer or shorter than the previous one because we need to talk about here I am going to use two more PowerPoint presentations. The previous video is about this part, the part one, and I hope in this one we are going to talk about the part two and the part three. Okay, so let's talk about the part two. It's about the input devices. Okay, what is an input device? An input device is just a piece of hardware used to enter data into a computer system for processing. What that means. So let me use this and I'm uploading the video and here I'm going to put input input devices. Input devices are all the devices that is used to send information inside the computer. For example, I'm going to use this one. We have the keyboard, we have a scanner, a joystick for games, a mouse, a light pen, webcam, microphone, um, what else? Sensors, and we have many, many, many more information. Uh, Devices that we are going to use them to put information inside the computer. That is input devices. Okay, a simple definition: an input device sends data or signals to a computer to tell it what to do. So why the input devices are required? Because computer need data to work with. That is just the big deal of this. Okay. Let's continue. So, common input devices with explanations. Barcode scanner reads barcode patterns or products to identify them quickly. For example, the one that we use in the school, school in the store, the keyboard, you use it every day. Digital camera, you use them every day just for take pictures and send the digital images to the computer. Microphone is the one that I'm using right now. Optical mouse is this one that I'm using right now that detects movement and controls on the screen pointer using light. The QR code scanner. This is the one that is used in our store, sorry, in the school. Touch screen, okay. Um, Resistive, two layers, detect touch by pressures, work with. I think this is okay. This part that says resistive and capacitive, um, infrared is for the touch screen. Okay, so the touch screen let users interact by touching the display. Different technologies include resistive, two layers detect touch by pressure works with any object. Let me try to show you the okay. I'm going to try. I think that this is something like this. For example, you have something here, you have something here, and you have another thing here. When you use your finger, let's suppose this is a finger and you use it to touch your screen, this blue part is going to be moved down to touch the red line. So doing this, you're sending a signal to the computer. That means that wherever you do, for example, this one, I am using my finger to move this. So this is the signal that I'm sending to the processor on my iPad and it tells to my iPad that the screen is moving. Okay. Okay, the capacitive use electrical chairs, work with fingers or special styles uses. For example, if I'm going to press with my finger, and the signal is that the um, screen needs to move. But if I use my Apple Pencil, is sending another electrical signal. That means that I am drawing. Okay. Okie dokie dokie dokie. Another one, we have 2D scanner and 3D scanners. Okay, so this is the common input devices and the explanations. Obviously, I'm going to share with you all these presentations. Okay, what is an output device? An output device is a piece of hardware that receives data from a computer and presents the information to the user in a readable and usable form. In this way, you are using your screen for watching what I am showing you. That is an output. And if you listen to my voice, if you can listen my voice, if you can hear me, that means that you are using speakers. That is another output device. So, simple definition, an output device takes processed data from the computer and outputs as text, images, sounds, or physical objects. Why the output devices are required? Because you need to know the results of the information or the activities that you are doing. So you use the input just to tells the computer to perform instructions, and you use the output for watching the results. Okay. Another, this is common output devices, actuators. I'm going to give an example. If you are getting inside a mall, let's suppose that the doors are closed, and when you reach the door, a sensor of movement reads that you are close to the door, sends a signal to the microprocessor. The microprocessor says, okay, there is someone else, there is someone in front of the door, and sends the signals to another device that is going to open the door. That is the actuator. The DLP projector project digital images or videos using tiny mirrors and light. Let me show you this DLP projector, this one, okay? And inject printer is the normal printer that you have at home. Laser printer are the printers that we have in our papelerias. LED screen, the one that, for example, you are using for watching this video. LCD projectors, projects images using liquid crystal displays. Okay, that is the best when you are using, for example, when you are in the cinema. For larger screens and presentation, the better is the LCD projector. LCD screens, common flat panel display found in laptops, monitors, and etc. And speakers and 3D printers. Okay, next one. Now, if we're talking about input devices, we need to talk about the sensors. What is a sensor? A sensor is a device that detects and measures physical changes in the environment and sends data to a computer or microprocessor to be processed. A sensor collects real world data like the temperature, light levels, water levels, and sends the information to a system. The purpose of sensor is to automatically monitor conditions, allow system to respond to change without human input, and improve accuracy to efficiency in systems like alarms, automations, and safety controls. What that means? The purpose of sensors is for avoiding human interventions. Okay, so let's suppose the same example in the mall center. You you step in front the door, and no, there is no a human person opening the door. The door opens when the sensors perceive that you are so close to the door, send information to the microprocessor, and the microprocessor says, okay, we need to open the door, and use the actuator to open the door. That is the purpose of the sensors. Okay. Now, types of sensors and their purposes. So let me do it like this. Okay. Why sensors are important? Because allow automations. Okay. So that means that the human is not need to check things. Enable real-time monitoring and alerts, and helping safety systems, environmental control, and smart technology. So, for example, we have acoustic sensor. That means that you are going to measure the sounds level. For example, when you are in a party están en su conjunto cerrado, en una fiesta, hay mucho ruido, hay unas normas del control del ruido, entonces alguien va con un acoustic sensor para ver cuántos decibeles están usando ustedes en su fiesta, y si superan esos decibeles, le llaman a la policía. Pero si lo hacemos de forma automática, tendríamos un sistema que mide los niveles de decibeles en ruido y automáticamente manda una señal a la policía. Acelerómetros. ¿Listo? Es usado en los celulares, por ejemplo, cuando ustedes están viendo un video y que lo ponen de forma horizontal, entonces él reconoce que usted lo puso en forma horizontal y pone el video en forma horizontal. Flow sensors measures the flow rates of liquids or gases. Is used in water systems on fuel monitoring. Gas sensor detects gases like monóxido de carbono, metano, oxígeno. Humidity sensor measures moisture in the air. Infrared sensor, level sensor, and etc. I'm not going to read all the sensors, but the things that you need to know is that the sensors is used for automation. Okay, so I'm going to share this presentation with you. So you are going to be able for checking all the sensors that I have here. Okay. Sensor data types and their uses. So this part focuses on knowing what type of data each sensor captures, temperature, movement, light, etc., and when to use each sensor by selecting the most appropriate in real world scenarios. So acoustic sensor, I give you the explanation in which moment you are going to use it. And the type of data capture is the sound waves. Do you remember when we talk about audio in first or second video? So the sorry, sound waves means that you are going to have this, and this is that the acoustic sensor is going to measure this. Okay. Accelerometer is going to measure the movement. Okay. Flow sensor is going to measure the flow rate of liquids and gases. And here you have the sensor, the data type that is going to be captured, the example of use, and why it is suitable. Okay. So I'm going to jump to this, and I'm going to jump to this. Okay. So how to select the most suitable sensor? Look at the environment or problem. For example, if you need to check if someone enters a room, you need an infrared sensor that detects heat movements. Okay. If you want to measure the moisture of soil, you are going to use a moisture sensor. If you need to check air quality for dangerous gas, you are going to use gas sensor. Okay? So you need to know which type of data you are going to measure. That means that depends of the type of data that you are going to collect, you are going to know which sensor that you're going to use. For example, is the temperature that you are going to measure, so you need a temperature sensor. If you are going to measure the movement, you need an accelerometer or maybe an infrared. You need to measure a liquid level, use a level sensor. Okay, so that's all for the hardware part 2. So let's move to the hardware part 3. Is this one? And oh my goodness, this is a little bit longer, but let's try to do this faster. So here we are going to talk about data storage. What is this? That is simple. That when you are going to talk about storage, that means that you are going to have a place. Let's suppose we have this box, and let's suppose that you are going to keep something inside a box. That is storage. Okay, so let's start talking about this. So key concepts. Here we have two kinds of storage. We have the primary storage and secondary storage. In this moment, we are going to start talking about primary storage. So, what is primary storage? Primary storage means that you are going to is the storage that is directly accessed by the CPU and is essential for a computer's operations. That includes the random access memory and the read-only memory. One is a volatile and the other one is not volatile. Okay, but maybe you are thinking, but Mr. David told us the previous year that primary storage and the secondary storage, this is volatile, and this is not volatile. And that's right. But here we have RAM and ROM. The ROM is non-volatile. But what is the difference? The primary storage is used for the system to be executed, and the secondary storage is just used for storing information. That is the other difference that you have. Now, eh, let's continue that. I think that in another slides, we're going to talk about ROM. Okay, so let's continue here. So what is primary storage? Primary storage is also called main memory and is the fastest type of memory in a computer because it is directly accessed by the CPU. It holds data and instructions temporarily while the computer is running. Okay, it's not the same that when you have a secondary storage. So the difference between secondary storage and primary storage is that the primary storage is faster but with limited capacity. Okay. Now, the two main types of primary storage are random access memory and read-only memory. That means RAM memory and ROM memory. So when we are talking about primary storage, we have RAM, ROM, and another one that I don't have here, but that you already know. So we have RAM, we have ROM, we have cache. And we are going to talk about later about them. Okie dokie. Let's continue. Definition of RAM is a volatile memory, mean when you turn off your computer, the information that you have inside the RAM memory is lost. Okay? The characteristics, fast access, volatile, read and write. That means that you are going to put, not you, the computer, not you. That is the huge difference between primary and secondary. In primary, that means that the computer is the one that is going to store the information in the RAM, not you. But you are going to use the secondary storage to save your information, but is with limited capacity. Okay, so example uses of RAM for running applications. Okay, so as much applications you want to have in your computer, you need to have lots of RAM. Okay, the RAM is used for multitasking. What that means? That, for example, in this moment, I am recording this video for you, and simultaneously, not at the same time, but simultaneously, I am uploading the previous video for you in YouTube. Okay, that means multitasking. Okay, an analogy, imagine RAM as a workbench when you temporarily place tools while working. The bigger the bench, the more tools or programs you can access quickly. Example, in another words, that maybe you are going to understand. Let's suppose you have a desktop. Let's suppose this is a desktop, and you have here your laptop. You have here something to drink. You have notebooks, books, pencil cases, and a lot of things. So, if your table, if your desk is too small, you cannot have a lot of things in your desktop. But if your desktop is so big, you can have a lot of things in your desktop. Okay, so that is the same with the RAM memory. If you have a lot of RAM memory, you can have a lot of programs used simultaneously. Okay, okie dokie, let's continue. What is ROM? Read only memory. ROM is a not volatile memory, but is a primary memory. And this is used when you are starting or tuning on your computer. Okay. And if you shut down your computer, the information is stored in the ROM memory is not going to be deleted. Okay. So characteristics is not volatile. That means that the data remains even your power is off. It's just read only. You cannot write or you cannot put information in the ROM memory. And is the permanent storage. Okay. So examples of uses of ROM. The BIOS. The BIOS is a small software that is stored in your motherboard. That is the one that is used when you turn on the computer. When you turn on the computer, the first memory that is read is the ROM. Why? Because in the ROM you have the first instructions to execute your operative system. Okay. Now, if you have, as I told you, irrigation system, the information about what the system is going to do depends of the moisture of the ground. Es decir, toda la información que se va a utilizar en el sistema está guardada en una memoria, ¿sí? Que normalmente es llamada como la memoria ROM. El dispositivo, el sensor de humedad, lee la información de la humedad en la tierra, se la manda al microprocesador y en el microprocesador va y lee la ROM memory porque allá están las reglas. Dice que si la humedad está por debajo del 10% es porque necesitamos agua. Esa información es guardada en una ROM, So devices like washing machines or traffic lights store the fixed instructions in the room. So it stores the information that is going to be used and the actions that is going to be taken. Okay. So let's continue. Why does a computer need both? Why? RAM is needed for speed and efficiency while running programs. And room is needed to store session instruction for booting up the system. Ok, explico así rápido. Cada vez que usted abre un programa, información de los programas es almacenada en la memoria RAM. En la ROM, usted tiene las primeras instrucciones. Bueno, usted no, el computador tiene las primeras instrucciones cuando se enciende. Cuando usted enciende el computador, se lee la memoria ROM y ahí están las primeras instrucciones de inicio del computador. Ah, el sistema está operativo está en tal lado, va y lo ejecuta. Ah, necesitamos activar todos los periféricos, activar el mouse, activar el teclado, activar la pantalla, todo eso está en la ROM. Por eso son ambas necesarias. Imagínese esa información de la ROM metida en la RAM. Se pierde, cada vez que se apaga el computador se pierde, lo cual quiere decir que si usted prende el computador no le va a prender. Por eso que necesita de las dos. ROM para que el computador inicie y la RAM para poder tener los programas abiertos. Okay? I think so. Now, what is secondary storage? As I told you, the secondary storage is the permanent storage of data. That means that you are going to, you, not the computer, you are going to use the secondary storage for save your files. I'm going to give you an example here. I'm going to open another one, this one, and I use my SS drive to save all my information. Okay, so I save everything here in my documents. So this is secondary storage. This information, it doesn't matter that I turn off the computer. The information is going to remain. Okay. Okie dokie. So the characteristics, that means that the secondary storage is not volatile. So that means that if I turn off the computer, the information is not going to be lost. Is larger capacity, but is slower than RAM and is used for long-term storage. Next one. There are three main types of secondary storage. So we have magnetic storage, we have optical storage, and we have solid state storage. So I'm going to start explaining everyone. When we are talking about magnetic storage, we are talking about hard disk drives. So let me show you here. Magnetic storage. Here, we're talking about your hard drive. This is a mechanical drive. This is used in older computers. Today's computers don't use this kind of secondary storage. Okay? The characteristics. Okay, how does it work? This use spinning patterns coated with a magnetic material. So let me show you what is this. I thought that I have images, but I am noticing that. Let me show you. Let me show you. I thought, okay, I think this one. This is a pattern. It's kind of disc that is. Let me show you with this one. If you notice here, this is a hard disk, and this is the pattern. Okay. If you notice, it's like we have one, two, three, and four disc inside this one. This is a spindle. Es una aguja. This is the one that is going to read information inside the hard disk. Okay, so that means with spinning patterns coated with magnetic material. So this material is magnetic. Okay, So let's continue here. Characteristics. Large storage capacity, cheaper per gigabytes compared with SSD. That means that if you are going to use this kind of hard disk, these hard disks are cheaper than SSDs. Ah, look at here. This is what I was telling you. It's like if you have a lot of disk inside a hard disk. Okay. The hard disk is slower than SSD. And for example, we have internal hard disk or external hard disk. Okay. Let me show you an external hard disk. External HDD. These one are external hard disk and internal hard disk is this one. Okie dokie. So let's continue. Optical storage. The optical storage is, for example, when you are going to start using CDs. So optical storage, the CDs. This one uses lasers. Okay. So that means that it is, yes, lasers is going to be used here. But let me, yes, I have images. And in a moment, I'm going to show you images. Okay. The optical storage, we have CDs, DVDs, and Blu-ray. They are portables. They are slower than HDD, hard disk, and SDD, solid state disk, and they have limited storage. We have this was the first one that we have in the market. Then we have DVDs. For if you notice here, we have 700 megabytes, and in DVD we have 4.7 gigabytes, and Blu-ray we have more than 25 gigabytes. Okay, let's continue. And solid state storage are this one. So the is this. If you notice, they are so different from hard disks, and these one are faster than hard disks. But if you want to have a lot of storage using an SSD, it's going to be expensive. Okay. Okay, examples. This one, the USB. This one is a kind of SSD and solid state drivers and SD cards. You already know the SD cards, but I'm going to show you SD cards. These ones. Those are SSD, and those are faster than hard drive. Okay. Let me check. Yes, we are recording. Now let's continue here. So why is secondary storage necessary? You know that RAM is volatile. That means that if you turn off the computer, the information in the RAM is going to be lost. Okay. Now, the operating system, software, and files need to be stored when the computer is turned off. So that is the reason that a secondary storage is necessary. Now, hard drive and solid state drives store more data than RAM, so making them suitable for large scale storage. So here we have a table that is in which you have a summary about the information that you already talked. Now, how the magnetic, optical, and solid state storage works. Okay, so we have different. Okay, so we have magnetic, hard drive, optical, CD, and solid state storage, SSD. Now, the secondary storage stores data permanently and is not accessed by the CPU. Who is the one that access to the permanent storage? We as human. Okay. So magnetic storage. So if you notice here, these are the patterns. Okay. This is a spindle. This is like this is like an arm with a aguja, I think so. And this is used to read and write. This is the read write head. Okay. And let's suppose that you can understand this. Um, think about a vinyl record. Vinyl, vinyl record. This one. So that means that this is going to make rounds, va a dar vueltas, 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 vueltas. Okay. And in these patterns, we have something that is divided by into tracks. Okay, concentric circles and sectors, smart divisions within tracks. I'm going to give you an example. Okie dokie. Okay, we have the hard disk, and the hard disk is divided in tracks. Obviously, this is circle, okay? But let's suppose that here we are going to talk about this part, and in this part is called track. And inside the track, we have something that is called sectors. Okay. So the information is stored here in all the sectors. Okay. And how does is stored? So a read, write, head moves over the patterns. So that means that we are going to have something like this that is going to move in all these parts for reading and write using electromagnet to read and write data. What that means que se van a utilizar electrones para leer o para escribir. ¿Listo? ¿En dónde? En todos los tracks, en todos los sectores del disco. ¿Ok? Now, the spins is the spins. Oh, spins. I was confusing spin with a spindle. That is different. The spins, this is our cycle, start giving rounds with a specific speed. That means, for example, that we have, this is the highest speed in a hard disk. 5400 o 7200 revoluciones por minuto. ¿Qué quiere decir eso? Que daría 7200 vueltas en un minuto. Esa es la velocidad. Y la información es almacenada magnetizando y desmagnetizando las áreas para almacenar datos binarios. ¿Cómo así? Entonces digamos que yo vengo acá, voy a guardar información ahí, quiere decir que lo voy a magnetizar. ¿Cómo? Usando los electrones. ¿Cómo así? Coloqué un 1 ahí. Voy a colocar unos y ceros, unos y ceros, unos y ceros. ¿Ok? So that is the reason that you learn about binary information. ¿Ok? Now let's continue. Characteristic of magnetic storage, high capacity, cost effective, but is slower than SSD and is easier to be broken. Okay, let's continue. Optical storage, CDs, DVDs, Blu-ray discs, and and more. How it works. Optical storage uses lasers to create and read microscopic bits and lands on a reflective disk surface. And so let me explain you here. You have your CD. Okay, so here we use lasers. Well, the computer use laser to read or write information. And you have something that is called um, bit and land. Okay, bit and land, something like this. Okay, in the disk. Okay, so here you have a bit, here you have a land. In the bit is 0, in the land is 1. Okay, and so it says when reading data, a laser beam is direct at the disk. This is the laser beam. Is direct to the disk. Okay. Light reflects differently from pits and lands, allowing the device to decode the stored information. What that means? If you are sending laser in the land, the way that this laser is going to be reflect is different than if you send the laser to the pit. Okay? And as I told you, there you have information, and obviously the information is going to be read and is going to be decoded. That is the only information that you need to know about this. Next one, characteristic of optical storage is portable. That means that you can have your CDs to everywhere you want. Long lasting, that means that if you put an imam in your CD, the information is not going to be lost. But if you put an imam in your hard drive, the information is going to be lost. Okay, it's slower than both hard drives and solid state drives, and is from limited capacity, as I told you and show you in a previous slides. Solid state flash memory, let me check if we are recording. Yes, we are recording, and we have 42 minutes in this video. Okay, how it works. Solid state storage uses NAND and NOR flash memory to store data. What is a NAND or NOR flash memory? So let me show you. NAND memory. This is a NAND memory. This is the one that is used in a solid state drive. Okay. Data is stored in memory cells, which are controlled by transistors. Each memory cell has a control gate and floating gate. That means that the electrical charge is going to determine the bits in ones or zeros. Since there are no moving parts, data access is much faster than in hard drives. How do you make, what do you think is this? No moving parts. If you notice here the only thing that you are going to have is one zeros, one zeros, one zeros. Talking about moving parts means that you are going to have this head that is going to move across the disk, and the disk is making rounds, is dando vueltas. So that means that it's moving parts. So in SS drives, we don't have this. That is the reason that this one is faster than the other ones. Okay. Um, Characteristics: very fast, more durable because it doesn't have moving parts. More expensive per gigabyte. So that means if you want to have an SSD drive, as much gigabytes you want to have, you need to pay more. Lower power consumptions. This is ideal for laptops and mobile devices. Okay, so let's continue here. This is a table comparison I am not going to explain it. You are going to have this presentation and you are going to be able for reading when you need it. Now, this is something maybe for some of you topic, maybe for some of you is not going to be um, a new topic, but I'm going to explain making draws. Okay, so you have your computer. This is your computer. Your computer has RAM memory. Here I'm going to put RAM memory. That means our primary storage. And you let's suppose that you are going to have an SS drive, okay, for storing data. This is your secondary storage. Remember that every time that you start running a program, you are going to put some information in your RAM. No, here. So let's suppose that with the red one, you open, in my case, OBS Studio. This is a software for recording screens. And I am using PowerPoint. So let's suppose that this part is going to be used for PowerPoint. And I am using Google Chrome. So let's suppose that here is used for Google Chrome. And let's suppose that now I am using Acrobat Reader. So this is for Acrobat Reader. If you notice, my RAM memory is full in this moment. But now let's suppose that I have opened this software that I'm using to show you my iPad screen. So that means that I am using another programs that is called Press Tools, but my RAM memory is full. It's completely full. So I don't have more space for opening 3U tools. So the computer, the operating systems, in this case Windows creates something that is called virtual memory. That means that I'm going to use my SS drive for use a small part for using it as RAM memory. That means that a virtual memory is the RAM memory emulated. Es como si estuviéramos emulando memoria RAM, ¿ok? Porque acuérdense que la memoria RAM es usada para almacenar información de forma temporal. ¿Qué información? La de los programas en ejecución. Si yo ya tengo mi memoria totalmente llena, les voy a mostrar acá. Supongamos que aquí en rendimiento, mi memoria en este momento está al 69%. Quiere decir que puedo seguir abriendo y abriendo y abriendo más programas. Si yo sigo abriendo y abriendo y abriendo, va a llegar el momento en que la memoria va a estar al 100%. Pero yo sigo abriendo y abriendo y abriendo. Entonces, ¿qué pasa? El computador, el sistema operativo, va a usar espacio de mi disco duro de mi disco sólido, va a utilizar un espacio para utilizarlo como si fuera memoria RAM, lo cual me va a permitir seguir abriendo más programas. Obviamente el computador se va a poner lento, pero that is the purpose of virtual memory. So, virtual memory, what is this? Virtual memory is a section of computer secondary storage in your hard drive or your solid state drive that is temporarily used as RAM when the system runs out of physical memory. It acts as an extension of RAM, allowing a computer to handle more process. Let me move this. More process than its physical RAM can support. Okay? So, how virtual memory is created and used? So, we have something that is called paging process. So, that means that let me show you. Always, I am going to use drawings for you. Okay. So that means that let's suppose that here we have our RAM memory. And let's suppose that is like a book in which you have your page one, page two, page three, page four, page five, page six, page seven, and page eight. Okay. So data RAM is divided into pages, like a small fixed size blocks. When RAM is full, pages that are not actively needed are moved to virtual memory. So let me explain you. Let's suppose that here we have the PowerPoint presentation. And if you notice in this moment, I have the PowerPoint presentation opened, but I am not using the PowerPoint presentation. Why? Because I am not, in this moment, I am using the PowerPoint presentation. In this moment, I am not using the PowerPoint presentation. Now, let's suppose that all this is completely filled with programs. Okay, so in this moment, I am not using the PowerPoint presentation, and now I am going to use to open 3U tools. That is the one that I'm using in this moment for showing you my iPad's screen. So the PowerPoint presentation is inactive. So is here we have my, let's suppose, hard drive or solid state drive. So this one is not being used. So the computer is going to put the PowerPoint presentation here, and here is going to be stored the 3U tools. This is the way that the virtual memory works. Let's continue. Swapping data between RAM and virtual memory. If a program needs data that was moved to the virtual memory, it is swapped back into the RAM, replacing another page if necessary. This swapping process continues dynamically as needed. Let me explain you here. So I told you that my PowerPoint presentation was moved to my virtual memory, but now I am going to use the PowerPoint presentation back. So the 3U tool is going to be moved to the virtual memory, and the PowerPoint presentation is moved again to the RAM memory to be used. That is swapping. Swapping es como un intercambio. Entonces, PowerPoint está inactivo, póngalo allá un ratico. Ay, vamos a usar el PowerPoint, tráigalo para acá otra vez. Eso es swapping. ¿Ok? And page file, swap file. Virtual memory is stored in a special file called the page file Windows or swap file, Linux or Mac on the disk. This size of virtual memory can be set manually or managed automatically by the operating system. I am not going to show you that. But let me try to do this faster. So here I have my computer, more options, and here I'm going to put here, yeah, I don't remember, administrar, I think so. No, it's not administrar. Skip up, mostrar más opciones. I forgot. Yes, I forgot how to do this because in Windows 11 is different, but intercambiar, tin, 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 tin. No, I forgot how to do it here because in this one is different, but here, no, it's not in accessibility. No, this is here in Sistema. And let me. Tin, 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 tin. No, later I'm going to explain you that part. And obviously, you are not going to be assessed by this. You are not going to have an IGCSE question about how to set the virtual memory. No, it's going to be as a concept. What is virtual memory? So you are going to say that virtual memory is the process of using uh, part of the secondary storage as RAM when you RAM memory is completely filled. Okay. Okay. Why virtual memory is necessary? So I already explained you. If you want to have more programs open, that is the reason that virtual memory is necessary. Allows multiple large programs to run at the same time. Okay. Even if RAM is limited. Prevent crashes when RAM is full by providing extra temporary storage and helps manage memory efficiently. Limitations is slower than RAM, increase the use of SS drive, and if you had a lot of swapping, remember that you are going to change information between the virtual memory and the RAM. If you have a lot of swapping, the system get slow significantly. Okay. Cloud storage. You already know what is cloud storage. Cloud storage is a modern data storage solution that allows users to store, access, and manage data remotely over the internet. So, what is data storage? Refers to the process of saving files and data on remote servers managed by cloud services. So, that means, for example, Google Drive, OneDrive. Okay, you already know that if you use something in Google Drive, the information is stored in Google services and not in your computer. The same with OneDrive. Okay, so how cloud storage works? So you upload files, the file is stored in multiple servers, and the user can access to and download the files from anywhere. Okay, so let me explain you here. This is my OneDrive. So all this information, I have it in OneDrive, but not in my computer. That means cloud storage. And I can, for example, I create these folders for you, but by the moment we are not using it. If you notice, I have a folder for every single student. Okay. And for example, I'm going to use the Luciana Zero, and here I'm going to be able for putting information inside. For example, I'm going to use this PowerPoint presentation. I'm going to drag it here. And in this moment, now I upload the presentation. I am able to download information. So I'm going to select it and I'm going to download information. But in this moment, she doesn't need it here. And that means that you are going to upload the file and you can download the file. And the physical storage still exists. Okay. What that means that if we are using our OneDrive, for us, this is we are using the cloud for storing information. But there is in any part of the world a huge computer called server, and your file is inside that computer. So that means that it doesn't matter that you are using cloud storage, the your information is safe physical storage in one computer that is not yours. Okay. So characteristics: remote access, scalability, automated backup, collaboration features, and security measures. Okay. Remote access is what I'm doing right now. Scalability. So you can increase or decrease your storage. For example, one of you use iCloud. For example, I use iCloud, but I don't pay for iCloud. That means that I have limited space of 5 GB. So if I want to increase my storage capability, I need to pay for it. Or let's suppose that I'm paying it, but I don't I don't need it anymore. So I stop paying. So my storage capability is going to decrease. Okay. Automatic backup, for example, here I have some of my OneDrives sync with my computer. And for example, if here in my computer I put something here, I'm going to do the same. So Luciana, I am going to do it in this way. I'm going to move, copy this, sorry, Control C, and I'm going to come here, Control V. So now in Luciana's folder in my computer, you have this file and automatically synchronize with the cloud here. If I take this and I delete it here, and if came here, look at that, the file disappears. That means that automatic backup. Collaboration feature is that you are going to be able to share your files with more students or more people. And security measures that the cloud provides encryption and authentication to protect your data. What that means? This information is encrypted, and then I can access to this information. I need to log in the OneDrive service. Let's continue. Advantages. You are going to be able to access wherever you are in any moment you want. You are going to have security. Um, you can have it free, or you maybe are going to pay for it. You are going to have backup and recovery, and scalability is easy to expand storage, as I told you. If I need to more, I need more storage, I'm going to pay. Disadvantages, you need internet connection. If you don't have internet, sorry, but you can't access to your information. Maybe you are in risk of hacking your information. So maybe someone is going to steal your information. For long-term storage is very expensive. Okay. There is no control over the server failures. For example, if the server of Microsoft talking about OneDrive service fails, you cannot access. Okay. And obviously, you depend on the service provider availability or esa cosa. What that means, let's suppose that you need more storage, but your provider, in this case, this is just an example, Microsoft doesn't have the service of giving you more than 5 GB. So you can have more space. Okay. It's used for personal use or obviously, obviously also for business means. For example, Amazon, Microsoft Azure, Google Cloud Storage, and more. Okay, let's continue. Advantages and disadvantages of cloud storage versus local storage. So, okay, when you need to choose if you're going to use cloud storage and local storage. Okay, so what is local storage? Local storage is this when you have your personal information inside your computer. Okay, in this case, I have this synchronized with my Google Drive. But for example, this one, I don't have it synchronized with Google Drive. So this is local storage. Okay, it's just on my computer, not on the web. Okay. So local storage refers you to your hard drives, your USB or external hard drives or memory cards. Okay. Now, for accessibility, when you are going to use cloud storage, you can access anywhere, but you need internet. If you have locally, you need your physical computer. Okay. For security, the information is encrypted, but the security of local storage is that is not exposed to online threats. Okay. but is vulnerable to hardware damage. What that means? Maybe you are not in danger for hacking, so nobody is going to hack your information, but your hard drive is broken, so you lose information. The cost. The only when you are talking about local storage, you pay just once for having your information in your computer. But if you need to pay using cloud storage, you need to pay month and month and month or by year. You need to start paying. When you have your local service, you pay just once when you buy the computer. Backup and recovery using cloud storage is automatic. But if you have local, you need to do it manual. What that means? That, for example, I am going to use an external hard drive to select all the information and copy all the information in my external hard drive. That means manual backup. Storage capacity. Your cloud storage is scalable. That means that you can upgrade your space, but in local storage, you cannot. You need to buy another hard drive to have more space and cloud drive is easy for collaboration. Local storage is not that easy. Cloud storage, you need internet. Local storage, you don't need internet. Okay. So here you have the advantages and disadvantages, okay, of cloud storage. Advantages and disadvantages of local storage. When to use each storage type. If you need Let's suppose that you use your computer just at home and not at the school. So you need information at the school. So there is the case that you are going to use cloud storage. But if you don't have internet and you need your information everywhere, you need to take the information in a USB, or you need to take your computer to everywhere you go. Okay. Now let's talk about hardware. So remember that um, when we talk about computers, when one computer has the ability to communicate with another computer, that means that we are talking about a network. What that means? Let me always so here I have one computer and here I have another computer. So if I want to send information from this computer to this computer, we are talking about network, but we need some devices to be able for share information. The first one that we need is NIC, Network Interface Card. This is the one that allows a computer to get communicated with other computers. We have NIC and we have WNIC. What that means? In this one, you use cords or cables. In this one, you do it wireless. Okay, let's continue here. This is what I already explained to you. But, let me show you here. When you are using a NIC, the NIC has two kinds of identifications. One is called IP and the other one is called MAC. This is Internet Protocol and this is, I forgot, Media Access Control. Okay, so what is the difference between them? This one is numbers that you are going to use, like for example, this one. Okay, and this one is called logic identification. What that means? That, for example, this IP, you can have it at school and you can have it at home. But the MAC address is unique and is given in hexadecimal numbers. That means that the NIC has a MAC that makes that this NIC is unique from the other NICs around the world. But the IP could be repeated. It's like, as I told you, we have your ID, su tarjeta de identidad, and you have a number assigned to Colombia, just in Colombia. There is not another teenager with the same tarjeta de identidad. But maybe in United States of America, there is another teenager with the same ID number, but it's for the United States of America. It's the same with the IP. Okay. I'm going to give you another example. Let's suppose that my name is David Reyes, and let's suppose that there is another person with the same name, an anonymous, David Reyes, but it's not the same person. What made us different? Our fingerprint. Our fingerprint is our MAC address. Is the identification that makes us unique. Okay. So let's come here. Now, what does a computer need a NIC? The NIC allows the computer to connect to the internet or a local network, allows the computer to communicate with other computer, and is used to data transmission. And obviously, the NIC has an identification that is called MAC address. Okay, so I already explained this. What is MAC? I already explained with the same example. So I'm going to move here. Okay, this is repeated. Okay, I'm going to delete this slide. I don't know why that one is repeated. Okay, so the MAC address is has an structure that is 48 bits long and is represented by using hexadecimal numbers. Look at, okay. Each MAC address is divided into two parts. The first part, for example, take this example 001A to B. This part identifies the manufacturer code. That means that is going to identify the device manufacturer. Let's suppose this is from IBM or this is from Hewlett Packard. Just an example. Okay. And the last three from 3C4D5E is the serial code to the device. It's a unit code assigned to the specific device. So, what that means? This part is going to identify all the NICs from Hewlett Packard. And this one is going to identify all the computers in Hewlett Packard. That is the reason that it is going to be unique. Okay? Okie dokie. How MAC is used in a network? When a device connects to a local network, LAN or Wi-Fi, the router or switch use the MAC to address the MAC address to ensure data is sent to the right device. I'm going to give you an example here. Let's suppose let's suppose that we have this computer, and I'm going to talk about this computer later. So let's suppose that here we have our router or switch, and this computer is connected to the switch. This connect is connected to the switch. Now, let's suppose that this computer has this IP, 192.168.10.5, y este tiene 192.168.10.2. And let's suppose that this computer is going to send one file to this IP address. But let's suppose that this computer was shut down and this computer is connected now. And this computer gets the same IP address. So that means that this package is going to be sent to this computer. And maybe it's a private message, and this person doesn't need that information. So that is the reason that the routers uses the MAC address. That means that the information is not going to be sent to the IP, it's going to be sent to the MAC address. That means that if the information is going to send to this computer and this computer is disconnected from the network, the package is not going to be sent to any other computer. Why? Because remember that this MAC address is unique. Okay, so let's continue. Key difference between MAC address versus IP. So the MAC address identifies a specific device in a network, is assigned by the manufacturer as permanent. The format is in hexadecimal and ensuring that the data is sent to the correct device. The IP address identifies a device location in a network. The network router can change. So the IP can change. The IP is given in decimal and routing data across the internet. Okay. Real world examples of MAC addressing in action. So I think that I already gave you a real world example. What is an IP address? That is called an Internet Protocol and is a unique numerical label assigned to each byte in a network. In a network. Let me explain you this because this is so necessary to be understood. Okay, so let's suppose that here, let's suppose that here we are in the school, and here we connect to the network. So here you got an IP that is 172, 108, and tan in this computer. Now let's suppose that that computer now you connected at home. So you are going to have another IP, maybe another IP, maybe the same IP. But that means that you are in a different network. That is the reason that I told you that this number is unique in a network. Why? Just in a network? Why? Because the school is a network, your home is a network, and maybe you have the same IP. But you cannot access from your home to the school networks, and you cannot access from the school network from your home because there are different networks. That is the reason that the IP is unique in a network. Okay, and the purpose is to allow devices to send and receive data over the network or over the internet. Okay, so we have two types of IP address: static and dynamic IP address. The static is that means that technician, that means the someone that gives you technical support assigned your IP manually. So that person needs to go. Let me show you here. Let me show you here. Let me show you here. And let me show you here. And I'm going to use this one. So here I'm going to put state, and here I'm going to select properties, and here I'm going to select this one. So when we are going to assign an static IP address, so we change this option here and we put this information. Okay, so that means that that is an static IP. That means that if you had that IP and you go to the school, the IP is going to be the same. Dynamic IP means that another device, in this case a router, is the one that is going to assign the IP, but in an automatic way. Okay? Okie dokie. And it means that if that is automatic, the with the time, that IP could change. It's not always the same. Okie dokie. So let's continue now here. So we have something that is called IPv4 and IPv6. So let me give you an example here. Here. What is the difference between IPv4? IPv4. In here, that means that we are going to use 32 bits in an IP address. What that means? I'm going to give you an example. 92.168.10.10.3. Every single number is going to be represented by binary, and this number is always in 8 bits. I'm going to give an example. 1 1 0 1 1 0 1 2 3 4 5 6 7 8. That 1 0 0 0 1 0 0 1 1 2 3 4 5 6 7 8. That 0 0 0 0 1 0 1 0, and another one here. We have 0 0 0 0 0 0 1 1. So if you notice, we have 8 bits, 8 bits, 8 bits, 8 bits, and if you add them, you have 32 bits. Okay. Now, IPv6. What is the difference? In IPv6, you have 128 bits. What that means? That means that every single part here is not going to be in 8, but in 16, I think so. Let me try to make this calculation. And it says 18, 10, 10. No, we are not going to have a 16. We are going to have, let me show you, 128. So we are going to do it like this. 128 dividido 4. Okay. That means that every single part is not going to be of 18, but 32. That means that the IP is going to be so long. Okay. Okay. So look at here. Look at this is an example of IPv4 IP address, and this is an example of IPv6 IP address. It's longer, too much longer. And if you notice, it uses hexadecimal. Remember that if you are going to express a huge binary number, is easier to express it in an hexadecimal. Total of addresses for around 4.2 billion of addresses, and in IPv6 3040 on decillion. So that means so huge. Um, Address shortage, yes. Many IPs are already in use. That means that in this moment, the IP address used in IPv4 is getting over. So we are closer to the limit of IP address in IPv4. But in IPv6, in this moment, there is not any network using IPv6. This one is designed to handle in future growth. So when the IP addresses are over, we are going to start using IPv6. Okay. Now let's continue here. Differences, I already told you. Okay. Differences in MAC address and IP. Listo? I think this one is repeated. What is happening with this presentation? Okay, it doesn't matter. But I think this one is repeated. But okay, don't worry. So, difference between MAC and IP. MAC identifies a specific device. Yes, I already showed you this one. Here. Media access control. So I'm going to delete this one. Oh my goodness. It's repeated 3 times. Okay, now real world uses of IP address. So, web browsing, where you are visiting a website, your IP address allows the website server to send data back to your device. Online security, websites can track IP address to detect suspicious activity and remote access. Business uses stacked IP address to allow employees to security access to company networks from home. I'm going to give an example. When you are visiting a website, for example, I'm going to write YouTube. This number talking about real is an IP address, and I'm going to show you. I'm going to use the not here. I'm going to use CMD, and I'm going to put yeah for ping www.youtube.com. What is ping? Ping is that you are sending packages to that page. And look at, I am sending packages to YouTube, and the IP address that responds is this one. That means that this is the IP address of YouTube. Let's do the same. Ping www.facebook.com. Look at, if you notice, the IP address is different. This is the IP address from Facebook, the one that is answer me. Let's try another one. Ping www Liceo de Colombia. Let me check. Liceo de Colombia bilingüe. I'm going to use this one. I'm going to use this one. I'm going to copy it and I'm going to paste it here. Liceo de Colombia bilingüe.edu.co, but I'm going to. That is the IP address of our school page. Okay. So that is web browsing. When you visit a website, your IP address allows to the website server to send data back or to your device. Online security. Websites can track IP address. So I'm going to give you an example. Let's suppose that I want to do something wrong with the page. I want to change something and I want to do something wrong with the page. So the server in which this page is located can track my IP address. So they are going to find that I did something with their pages. So they are going to punish me. Okay. That is online security. And remote access, let's suppose that I am going to use an static IP address, for example, to check the video cameras from here, from my home, and I want to check the video cameras at the school in real time. So the school needs a static IP address, and I'm going to use a software that allows me to access remotely. Okay, let's continue. Now, a router. A router is a critical device in a network that directs data between devices and different networks, including the internet. If you don't have a network, you cannot access to the internet. Okay? So a router is a hardware device that connects different networks and manage traffic data. It ensures that data is sent to the correct destination. Okay? So we have the router here. Let me delete this. And now we have one computer. I already explained this. Another computer and another computer. And this is our router. All the computers are connected to the router. And if I want to send one information from here to here, the router is the one that is going to ensure that information arrives to the correct device. Add that information is not going to take with a ground device. Okay? Okie dokie. Key functions of the router. Send data to a specific destination. I already showed you. The router receives data packets from one device and forwards them to the correct destination. I already showed you. It uses the IP address to determine where to send the data. And if the destination is within the same web network, it sends the data directly. If the destination is on the internet, it forwards the data to the internet service provider. Okay? I think it doesn't need any other explanation. Another task of a router is the one that is going to assign the IP address. Do you remember where I talked to you about static and dynamic IP address? The router is the one that is going to use something that is called dynamic host configuration protocol, DHCP. This is the one that is going to assign the IPs automatic. Automatic. Okay, I am making a draw. I don't didn't see it. The HCP, Dynamic Host Configuration Protocol. So the router has this service, and this service is the one that is going to provide to the computers the IP in an automatic way. Okay. Okie dokie. And is the one that ensures that each device on the network has a unique local IP. I don't know why I have a lot of slides duplicated. Okay, and okay. Okay, the router acts as a gateway between local network and the internet. What means? So let me show you. What is a gateway? Gateway is like the door that you use to go inside your home and go out from your home. So there is no other way that you are going to go out. Obviously, maybe you think, yes, through the window, but no. Okay, so you are going to use your main door to go outside your home and to go inside your home. That is gateway. That means that this computer in the same network, let's suppose that this is your parents' computer and this is your computer. They are connected by a router. So that means that the router is the door that is going to be used to go out to the internet. Okay. Okie dokie. It ensures that private IP address using local networks can communicate with public address on the internet. I'm going to explain you this. This Your computer, when connect to the router, gets an IP, and this IP is privated. Privated. But your router or modem has a public IP. This one is that allows the computer to go outside to the internet. So that means that the privated IP is going to get communicated to the public to go outside to the internet. Okay. And uses network address translation, NAT, to convert local IP address to a public IP address when access is to the internet. So that is the way that I told you, that is the private IP address communicate with the public to go out to the internet. Okay. Tin, tin. Okay, that's all. And this one, router versus modem. You know that to go to the internet, the ISP, the internet service provider, put something at your home that is called modem. Modem. A modem is not a router, but today's modem acts as a router. Okay. So the purpose of router directs data between devices and networks. The purpose of router connects a network to the ISP, Internet Service Provider. The router manage IPs, is the one that assign the IP addresses. The modem, no. The modem just provides internet access. Use. The router sends data between computers in a home network, and the modem provides access to the internet. But many modern routers, okay, perform both options. That is the reason that I told you that today's modems acts as a router. So that means that today's modems assign IPs, give you access to the internet, send packages between computers inside the networks, and send packages from your computer to the internet. Okay. So, guys, I hope you find this video useful. 1 hour and 40 minutes almost. Oh my goodness, so long this video, but it's so necessary. So, guys, if you have any question about this, let me know it. So, bye bye.